because so the currents. Right.
So the purpose of using this IPS system, isolated power supply system in hospital, is to avoid or prevent the electric hazards, electric shock hazards for the patients. And how it is obtained? In IPS we use the isolating transformer, and this isolating transformer has a galvanic separation between primary and secondary winding. And due to this screen, it blocks or it suppresses the eddy currents, stray currents, unnecessary currents to flow on the secondary and ultimately to the equipment and to the patients. So that is why, because a normal human body resistance against electric hazards is 1 kilo ohm, 1000 ohm. Okay, but when you compare it with the patient resistance, that is very, very, very low because of the abnormal condition. So due to that, we have to avoid even a micro fraction sort of electric shock as well to flow in the equipment or in the patient. So for that purpose, we imply the isolating transformer which blocks all eddy and stray currents and give a clean supply, a pure voltage to the secondary distribution network. So it has ratings from 3 up to 10 kVA. For one system, we can use maximum 10 kVA transformer. This is according to the healthcare hospital standards. And in this one, we do have the primary winding from 0 to 230 volt. Then we have the secondary 0 to 230, and this is the earth cable from the source, and the small wires are for the temperature sensor or the thermostat wiring. Because this transformer is monitored also continuously for the possible alarms. So that is the component number 1. This is component number 2, which is called insulation, load and temperature monitor. So the job of this device is to continuously monitor the whole distribution network for insulation resistance, for transformer overload and transformer over temperature. So all alarms coming in the IPS panels are detected and signaled by this particular device. And then this yellow device which you see behind the circuit breakers, this is the automatic fault locator or automatic circuit locator, because whenever there is a supply circuit failure, so this unit detects and signals the number of the failed or faulty circuit, and it displays in all the designated remote stations. So this is one way, and then on the top is the distribution scheme or the apparatus. This is the outgoing circuits. Here is the incoming power terminals, and then we have this thermostat. Okay, and also this brown device or this brown CT which we see on top of the transformer, this is the load current monitor, which is housed only on the phase wire. So this gives you the current information in this monitor in form of the percentage. So for example, if the current is 10%, the output of the transformer is 22 amps. So it means that right now it is having 2.2 amperes in the display. So that is how the current percentage is described in this. So this is like a basic theoretical information, theory information. When you are doing the maintenance or the service, the first thing that you do is open the panel and check whether it's overall clean. It should not be very dusty. If yes, use a low or medium speed blower to make a cleaning spray on it. Then you check all the possible connections in front of you, whether all connections are intact, tight, there is nothing loose on the transformer or on this particular monitor, okay, or on the power terminals on the circuit, outgoing circuits. That's what we check. And then We check also the voltage on this isolator. Like you have to use a fluke multimeter and see what voltage you are getting, 230, 240, whatever is applicable. And that you note, and after that you check the alarm simulations. So first alarm is your circuit fail, or we also call it insulation fault. The way to check that is insert this fault. This is basically a fault also, we make it ourselves. So just plug it in the outlet, in the IPS outlet in the room, and then as soon as you insert it, immediately an alarm is signaled by this device and also in the remote stations. And then you are able to see the panel number, which is this one, this label, plus the circuit number, the breaker number. It comes in the display to tell you, okay, in this particular circuit we have the issue. And once that is displayed, that circuit needs to be checked and rectified, and then you can remove this plug after that. This is just for the testing purpose. In actual also, it happens in the same way. When there is an actual alarm also, you need to see exactly which circuit information is coming, and then that needs to be rectified. So you don't need to check all the circuits one by one. That time is saved with the help of this automatic location. Second thing you check is the transformer overload. And the way to check that is we have to change the current setting in this device with the menu option. There is a built-in menu, and we change the alarm current setting in that. Right now it is 22 ampere according to the transformer capacity. We change it to 5 ampere, and you connect a load, any load higher than 5 ampere in the outlet. And then you ultimately see the transformer overload alarm popping up.
But it will trip, right?
No trip at all.
There is
Nothing.
no password for setting?
Sorry?
No password?
I'll come to that. So this way, you check the overload, and when there is a transformer overload, you see the current display here 150%, 160, 170. I mean, as soon as it crosses 100%, you get the overload alarm. Even in the actual scenario as well, when actually you get this information, this alarm, so the current is higher than 100% in the display. So once that appears, then you remove it, change the settings back to the original according to the transformer, and the overload is also simulated and checked. Then the third alarm is the transformer over temperature. There is a heat dissipation because it is a transformer, it's a power supply, and to control that dissipation, we use this cooling fan, okay, and plus the filter. So basically the air is thrown on the transformer and it comes out of the filter. So it's front ventilation cycle. Okay. And then it is auto connected with the thermostat also for the automatic operation as well. If the temperature is sufficiently low, the fan goes off. If the temperature rises, the fan gets on. So it's auto set according to this. And to simulate, to trigger the temperature alarm, you see a terminal Z on this device. This is coming from the thermostat. You simply disconnect it and the temperature alarm is activated. Here the degree C will flash, and in all the remote stations you are able to see panel number, and it will say the transformer over temperature. So at that time you need to say, why is it a real temperature rise, or a fan got damaged, or something wrong with the thermostat. These are the things that need to be checked at that time. So these are the three major alarms that you need to simulate and check. I don't know if there is anything else in your list, or that's all. Yeah.
I have one.
That's it, guys.
I have one.
Yeah.
If the circuit is overloaded, the transformer will not trip, but the breaker will trip or not?
In the overload, no, breaker will not trip.
Only for unless it's
Only alarm.
LCD.
Only alarm.
It's
Yeah.
isolator.
Exactly.
Can we make
So
sample
Hmm?
circuit? We will test.
Yes, no problem. Sir.
Go ahead.
Next room. Paisal,
Go ahead.
go with him. You want to check?
Procedure.
I
Other
think
side.
there are
Sir.
2 rooms here. Are there 3?
Procedure. Yeah.
Just put it in any one of the outlet.
Can we measure the output voltage of the
We have the meter.
yeah. Line to neutral, neutral to
You can check on the transformer. You can check it here on the main isolator.
None.
It's up to you.
Because some
They will check,
locations
they will check, they will check.
there are reading
Because they are going to.
neutral
Their
to
people.
50 volts. Should be zero.
Come by. 150.
Neutral to
Here. Wait, first voltage. First voltage check. Check the voltage.
don't even have a neutral.
Here, check.
चेक करो कितना वोल्टेज है
So because
So with reference to earth, when you measure L or M, both will give half of 230 volts.
because I remember this
That is the input.
Siemens guy, there is what is the interventional radial, there is one machine
Oh, yes.
they don't want to plug because they found that the neutral
240 there
That is a normal
Okay.
IPS socket, healthy IPS socket.
no
ऊपर थोड़ा ऊपर से
Only L to N will be 230 volt, L to N will remain 230 volt, L to E
Okay. So now you go for test.
half of that. Always.
Check. No problem. That is also isolated.
This is normal.
Okay. Same
There is no
voltage.
neutral.
it's like
That's
line.
Yeah.
Kaya nga yun yung saksak dahil nag-aaral sa mataas na
That is isolated. Okay. Check other side. Go with you. Yeah.
रूम में लगा के
So,